Hello student. So today I will start next part of this chapter. Firstly I will start if magnetic field is not passing perpendicular through surface. As shown in the diagram, magnetic field line passing at an angle theta with direction normal to the surface of the conducting coil. Now here magnetic flux, by definition of magnetic flux, magnetic field lines are those which passing perpendicular through the surface. Here we'll take the cos component of the magnetic field, which is passing perpendicular through the surface and parallel to the area vector A. Thus magnetic flux phi V is equal to AB cos theta, or it can be written phi V is equal to A dot V. Also it can be write V dot A. Why? Because dot product is commutative. Here now to discuss some special cases, if angle theta is equal to 0, then magnetic flux passing through the surface is equal to VA cos 0 equal to VA, thus flux is positive. Second case, if theta is equal to 90 degree, then phi V is equal to VA cos 90 degree. Here cos 90 is equal to 0, therefore phi V is equal to 0. So in this case flux passes through the surface is equal to 0. Third, if theta is equal to 180 degree, then phi V is equal to VA cos 180 degree, or equal to VA cos 180 is equal to minus 1, then get phi V is equal to minus BA. Here flux is negative. Here magnetic flux is a scalar product of A and area vector A and field vector V. Here magnetic flux is a scalar quantity. Here SI unit of magnetic flux is Tesla meter square or Weber. Also in CGS, 1 Maxwell is equal to 10 raised to the power minus 8 Tesla meter square. Dimensional formula of the magnetic flux ML3 T minus 2 A minus 1. तो स्टूडेंट यहाँ तक का जो पार्ट है, अभी तक हम लोगों ने इस पूरे पार्ट में जो हमारा ये मैग्नेटिक फ्लक्स टॉपिक था, इसमें हमने केवल और केवल हाउ टू फाइंड द मैग्नेटिक फ्लक्स एंड also study on what factors magnetic flux to be depend. Or here in this I have to discuss, there are three cases. First, when theta is equal to 0, second when theta is equal to 90, and third when theta is equal to 180 degree. Now we will know phenomena of electromagnetic induction tells us how to induce current or EMF. How to induce current or EMF. Basically about this, if we have to see the formula of magnetic flux, so phi V is equal to AB cos theta. Faraday doing some experiments and explain this using using these observations by Faraday's experimental observations, how to induce current or EMF. There are three factors, or it may change the value of magnetic field. We will change the magnetic flux linked with the coil, or we will change the area encloses of the conducting coil, also change the magnetic flux, or may change the angle theta, can be change the magnetic flux. So here we have to discuss, there are three observations. First, when the magnetic field B is varying. If we have to see in the diagram, here the magnetic field directed normally inward, in which a conducting coil of area A is placed. Here in this, firstly we assume that area A and theta remains constant, only magnetic field B is varying. Here, if magnetic field B is varying, then flux encloses through the coil is to be changed, then induced EMF is produced. Then if conducting coil is a closed loop, then an induced current is produced. This is the first way to induce the current. Now have to see the second case. Here in the second case, I have to take in area A is varying. In the second case, area A is varying and taken magnetic field B and theta remain constant. How to area A is varying? If conducting coil to be shrink or conducting coil to be expand, अगर यहाँ पर कंडक्टिंग कॉइल श्रिंक होता है तो उसकी एरिया डिक्रीज होगी, और अगर वो एक्सपेंड होता है तो कंडक्टिंग कॉइल की एरिया इंक्रीज होगी. तो देयर आर टू वेज इन विच यू हैव टू कंसीडर area of the conducting coil are varying. If area A is varying, then magnetic flux linked with the coil is changed by the law of EMI. Magnetic flux linked with the coil is changed and induced EMF is produced. Then an induced current to be flows through the coil as shown in the diagram. Now here in third case, theta angle theta is varying and field V, area A remains constant. Here in this condition, here to be considered, the conducting coil are free to rotate or by doing some work to be rotate the coil about the given axis with the angular velocity omega. If the coil to be rotate about their axis, then angle theta between field vector V and area vector A gets changed. Then flux encloses through the coil to be also changed and induced current to be produced. Here in these three observations, I haven't to discuss कि what is the direction of the induced current. Only here I have to explain this, how to change the magnetic flux linked with the coil and induced EMF is produced. As the usual direction is shown here, in this anti-clockwise, also in here anti-clockwise, and and third one also an anti-clockwise current. So thus I have to concluded three cases: an induced current to be produced due to change in magnetic flux encloses through the coil by changing the magnetic field B, or area A, or angle theta.